Hello! Welcome to Day 3 of Java Fundamentals. This is a free 6-part course by the Auxi Project aiming to introduce you to some of the fundamentals of Java and how to think like a programmer. For a playlist for all the parts in the course, you can click the link in the description box below, and to see more videos like this one, you can visit our channel. Alright, so in today's lesson, we'll be learning about conditionals and how to use our first conditional statement. Before that though, I'd like to review a very important concept with you all. Last class, I introduced variables to you, but we didn't get to do any programs focusing on the topic. So we'll spend the first half of this class on that, and then we'll get into some if-else statements. So, variables. On the screen, you'll see that I've attached a little clip art of a box with a label on it. It's there because that's exactly how I want you to visualize a variable. A variable is like a box that you can name and store things in. So let's hop onto Replit so I can better demonstrate. So throughout this course, we've already used variables quite a bit without you really knowing what it was. If we take a look at the program we did last lesson, we can see that at the top 3 lines, we already had a spot where we declared variables. Now, variable declaration means you want to start, so declare a new variable. And if we go with our box analogy, it's a lot like getting yourself a new box. Now that we have our box, we have 2 things that we have to do next. One is labeling the box, and the other is putting something inside the box. Let's take a look at our first variable on line 4, and I'll just delete these to make our code a bit more clear. Here, we can see that there are 3 parts to this command. We have int, int, and we have a, and then we have 13. So what int means is it's the keyword that declares the type of box that we're using. We're using an int box, an int box, and an int stands for integer. That means this box is specifically made to handle integer values. A is what we labeled the box. Not a very creative name, I know. Maybe I should have named it something more fun. But for this lesson, let's name it variable 1. So we've grabbed our Sharpie, we've labeled the box variable 1. And 13 represents what we stored inside this variable. We've put the value of 13 inside this box. Now this variable can change. It is a variable, so we can simply change what's inside by putting the variable's name, an equal sign, and then the new number. Note how we don't need to put int again, because int would be declaring a new variable. We'll actually get an error if we try to put an int with the same name as our previous one. It says duplicate local variable, which means that it's giving us a little heads up that we've duplicated this twice. So we don't want to do that. We're keeping it as variable 1. So I've mentioned that we could store any number in here and it would work. That is the case. We can even store negative numbers. So maybe something like negative 97. That's completely valid. We don't get any red underlines. Oh, well, we just did for a second. But we don't get any red underlines because the computer is completely okay with this. Now, what if we wanted to store a letter inside instead of a number? So let's give it a try. Let's say we want to store, I don't know, the letter A. First letter in the alphabet. It's a fun letter, but Java doesn't like it. It gives us a red underline, and it says A cannot be resolved to a variable. What that means is A doesn't work for this box. That's because this type of variable can only store numbers. Like I said, it's an int, an integer type. If we wanted to store letters, we have to use a different type of variable, and it's a lot like using a different box to store something that doesn't fit. we have to use a different box because letters don't fit in this box meant for numbers. So to declare a variable for letters, we have to use the keyword char, C-A-R. And char stands for character. So you can probably guess that this code was made by an English person. It's helpful if you know English. With this char box, we can store any character we want in there. Like we can store letters, numbers, symbols. Let's give it a try. Let's name this box variable 2, and let's try storing an A. Now, we do get a red underline again, and that's because there's one more step we have to do when declaring chars. That is to just wrap our letter in some single quotation marks. Apostrophes? Yeah, the apostrophes. I'm going to delete this because that's just going to give us an error. Now with this char variable, you can store any letter you want inside, like it could be a B, it could be an N, Z, and you can store symbols, so an and sign, an at sign, all of that is completely valid. So let's write that down here. This can even be numbers, but the thing to note is that char boxes can only store the symbol, not the value of the number. So if you tried doing addition and subtraction with the numbers stored in char boxes, it wouldn't work. It's like doing math with hashtags and dollar signs. It just doesn't have a numerical value attached to it because the char just stores the symbol. Let's write that down for ourselves. Okay, so what if we tried storing multiple characters in a char box? So we had something like this. What would happen? We get a red underline, so we get an error. And Java says invalid character constant, which basically means we can't do this. So let's scratch that out. The problem is, char boxes are only made to store one character. If you try to store multiple, the box won't be big enough. And that means we have to get ourselves another box. And this box is called a string. Oops, a string. And the capitalization is intentional, so the S has to be a capital. To declare a string variable, you just replace the keyword char with string, and then, we'll name it as usual. Let's call it variable 3. And then we can put stuff inside. Say we want to put ABC. We get another red underline because you have to wrap the contents not in apostrophes, but in quotation marks, so the double ones. Anytime you want to tell the computer to treat words as text, you just wrap them in quotation marks. Oh, this might be good to write down. and you want the computer to treat words as text, wrap the text in quotation marks. And that's why, when we were outputting to the console in lesson 1, we put hello world in quotation marks. You guys remember that? And then we had like a system out print line. Back then we didn't know too much about strings, but when we wanted the computer to print out hello world, we had it wrapped in these double quotation marks, so we could tell the computer, please treat these as text. So yeah. On that note, why do you think a string is named a string, not something like a word? Because that would make more sense, wouldn't it? We have the keyword word instead of string. The name actually comes from what that type of variable is. When you declare a string variable, you're actually declaring a string of chars. So a string of characters, which is essentially what a word is. That's pretty interesting. Alright, so we have a type of int box, we have a type of char box, and we have a type string box. But there's still one thing that these three boxes can't store, and that is the value of decimal numbers. So if I had a number like 1.23, the string could technically store it. It could store the symbol for 1 and the symbol for decimal and then the symbol for 2 and 3, but it wouldn't store the value of that number, so you couldn't do math with it. Because the string is kind of like our catch-all. It's the biggest box there is. It can store all sorts of garbage, like letters, numbers, symbols. It's as big as it gets, but it can't store values. What we need to store a value of a decimal number is a box called a double. And we declare this the same as any other variable. And then we don't need to wrap it in anything. We just put our number in and it's good. So doubles are kind of like the fancier version of ints. You can store decimals and integers. So technically you could use a double to store 13, but honestly typing int is faster than typing double, so most people don't use it unless they have to. Programmers are always going for efficiency. So let's write that down. Doubles store values of okay. So these 4 types of variables are basically all you need to store every type of item. There are other variable types too, but we won't be using them in this course. But of course you're free to do extra Googling if you're curious. With our next project, we'll need to use something called string concatenation. Sounds really fancy, but we've already been using it. Let's clear this out so we can talk about string concatenation. Concatenation basically just means connect. So it's basically when you connect strings together. To give you an example of this, let's try printing a sentence that tells other people our favorite animal. So something like, my favorite animal is blank. And what we need in this blank is a variable. Now's the time to ask ourselves, what type of variable? Well, we're expecting users to input a word in here, which means we'll need to use a string. So let's do that. Let's go up here and make a variable. We'll declare a variable as usual, string, and we'll give it a name. It makes sense to name our variable favorite animal, since that's exactly what it will be storing. And then we'll have an equal sign, and that's our variable. With this, we've gotten ourselves a box. We've labeled it favorite animal. Now all we need to do is put something inside. But before we get there, let's hop over to line 6, and we'll first try printing this out to the console. What we need for that is just a simple output command, system.out.println, and then we can put a sentence inside. My favorite animal is. And like I said earlier, for the computer to treat this as text, we need to wrap it in quotation marks. Everything should be go. When we run it, this is exactly what shows up in the console. And it is what's inside our quotation marks, so everything's working great. Now's the part where we want to replace the blank blank with our variable favorite animal. So to do that, let's first delete this blank blank. We'll replace that blank blank with favorite animal. Now we don't want our computer to treat favorite animal like text, so we'll take it out of the quotation marks. And I'm also going to widen the window a bit, so there's a bit more room to see. What we have here is almost complete, except these two things need to be connected just with a simple plus sign. Now if we run it again, we get this sentence. My favorite animal is, and it doesn't print out favorite animal because we haven't wrapped that in quotation marks, so it doesn't treat it like text, it treats it like a variable, and right now in our variable, it is empty, so that's what it printed out, nothing. To change this, we can simply put something inside. My favorite animal is the giraffe, so I'm putting that in here, and what should happen is it prints out a completed sentence. Oh, but let's add a space over here. When a string is concatenated, the computer goes immediately from the S to the giraffe. And it doesn't know to add a space, so we'll need to add that ourselves. It's up to us programmers to manually fix the problem. My favorite animal is giraffe. Well, the sentence is a bit awkward. Alright, so that's it for string concatenation. You just put strings beside each other and have a plus sign in between to connect it. You can even connect more text after your variable. So if I wanted to ask someone what their favorite animal was, say I wanted to add another part of the sentence, just by simply adding a plus sign should work. Yeah. My favorite animal is giraffe. What's yours? With this, we know everything we need to get started with our next activity. We are going to making our very own Mad Lib. And Mad Lib is basically a word game that creates a story based on the words you put in specific places. So let's try doing one together to get a feel for what we're trying to achieve. I've opened up an ad lib of the song Firework by Katy Perry, and you're free to follow along, or you can choose your own if you'd like. But basically, we'll enter words in these blanks corresponding to the type of word that it suggests, and then at the end, we'll play it, and it will fill in all the blanks in the song with whatever we put in. So let's give it a try. For an adjective, we could randomize or we can have fun. For the sake of time, I will randomize all of these. And we can see some pretty interesting words in here. I'm very curious as to how it'll turn out. We have trying for adjective, star-nosed mole for animal, barbells. Interesting. Hopefully that's going to be interesting. We have jaded twice, so let's change one out to be fun. Colorful. And animal. Oh, there was a bit of an error with their randomization. Let's fill it in with one of ours. We'll choose a giraffe. We'll bring back the giraffe. A verb-based one slurp. Barbells again. Oh no. Let's try shoes. Okay, this looks pretty fun. I'm gonna switch out a few more verbs to make it more interesting. Alright. I'm excited to play this. Let's give it a shot. And it has printed out our new lyrics for us. Do you ever feel like a trying star-nosed mole? And so all the places where the original lyrics were, they've replaced with whatever we put in. And how they do this is with, surprise, surprise, variables. So that's what we will be doing today. It won't be as long as this one. It doesn't have to be. Of course, you are definitely free to make your stories long. But I would recommend 4 or 5 variables at least, just to get yourself started and more comfortable with working with them. So let's go back to our slides. Alright, here I have a template that you're free to use. If you want to get creative, you're more than welcome to. But I'll let you go off to Replit now and make your ad lib, and then we'll reconvene once we're done. So, here's your task. If you're using this template, you'll need to let the user input a noun, a color, a number, a place, and a verb ending in ing. Once you do that, you'll need to store what the user inputted in a variable, and once they have put in all their words, you'll want to print out the entire story with the user's words, replacing these blanks. So for example, if in the output it says something like, enter a noun, and then I'm the user, I put in shoe. What I want you to do at the end is have shoe replace this noun up here. So it should say the shoe is shining, which doesn't make sense, but that's all part of the fun. So hop to it. I'll show the answer in a bit. You can pause the video now and continue watching it for the solution. Welcome back. Hopefully you had lots of fun with your stories. We're now going to go over the solution and code it. Your code might not look exactly like mine does, but it's good to stick around and make some comparisons to see if there are any strategies that might improve and optimize your code. So let's start up a new replet. And we're going in Java. Let's name it Mad Libs. So before we start typing away, let's first discuss what steps there are. So we know that we'll need to print out the story, so we'll need an output command. And we'll also need to take input from the user. So we'll need to take input 5 times and store it in 5 different variables. I'll leave the template here so we can all see it. And yeah, let's start by declaring those variables because we know that we'll need to do input. So I'll just delete everything except for the template, which we'll need in a bit. And we'll make our variable declarations. So in here, our first variable will be a noun. So we'll need to use a string for that because we expect the user to type in some words or a word. So a string is the only type of variable that can store multiple characters. We'll leave it empty so that our user can fill it up. Next, we'll need a color. And the color will also be a word, which means we'll also need to store it in a string. Then we want them to give us a number. That's where it changes. A number is usually stored in either an int or a double. Now we don't know if the user is going to put in decimals or not, but it's better to use a double in case the user does, because a double can store both ints and in decimal numbers. So it's better to use a bigger box to store something that we don't know yet. And we'll name it degrees, just to be more descriptive. We'll set it to 0 for now. And we have 2 more variables. We'll need a place, which will also be a string. And we'll need a verb. Okay, so now we have our variables declared. We can start taking input from the user. And if you need a bit of refresher on how to get input, check out the first lesson where we talked about input and output. So if you remember, input requires a scanner. So let's import a scanner from the library. We go up here. Usually you put anything you import at the very top, just as a convention. And the syntax for that is import java.util.scanner. Don't forget your semicolon. We'll come back here. Now we can start using scanners. So let's get ourselves an input scanner. Alright. Now we want to get some input from the user. So let's print out a line to ask them for some input. Oh, you know what? Since this is input, it would be better to just use a print instead of a print line. System out print, enter a noun. Once we have that, we can get input for our first variable, which is noun. We'll make that equal to input.next. Next, we want a color. So for efficiency, let's just copy and paste. You'll find that it happens quite a lot in computer science because it gets pretty repetitive. So sometimes it's just best to save yourself the typing and use a good old Control-C. Next, we need degrees. Degrees equal. Now there's something to note when we're working with doubles. Instead of just simple next function, we actually use a next double function. This tells the computer to expect the next number to be a double. There's also something similar. It's called a .next int. And that's for telling the computer that the next input will be an integer. Okay. Oh, we should also have a line asking them to enter it too. Enter a number and enter a place. And last but not least, enter a verb ending in ing. And we'll store this in the verb. Okay. Now if we run this, we should get these questions and we should be able to enter something. Let's give it a try. So it asks us to enter a noun. Let's go with bed. Enter a color. Yellow. Enter a number. 36. Enter a place. A swimming pool, I guess. And enter a verb ending in ing. Well, running. It's nice simple things. And like that, our program has been ended because it's reached the end. It's reached line 28 and the next line is the end. So far it is working properly as we expect it to, which is great. It's good to always run your program to test it to make sure it actually is running properly before you start coding more stuff. Because once you have, 50 lines, it's way harder to debug if there's a problem than if you only have a couple of lines. So it's good to test in sections. Our next step is to print out our story, but with these variables replacing the blanks. So let's start off by printing out the output. So we'll get an output command in here. And we'll copy and paste the template side. Let's drag it over. Awesome. Now, anytime there is something we need to replace, we'll need to kind of slice the code here. So let's split it. split it by adding quotation marks on either side, and then have a plus sign. Now we need to stick in our own variable. And we just need to rinse and repeat for all the other ones. So first we split the text, and then we put in our variable name. Then we have these plus signs. Same thing over here. Okay, this should be it. Now, when we get to line 30, it should print out this story with all the variables replaced. Let's run it again. And we'll type in what we did before. What did we put here? 56? Oh. So the program is run, but it didn't go exactly the way we expected it to. That's okay, it's completely normal. We'll have to go back and make some small edits. So what I can see right away is if we had an extra ln over here before we have our story, that would be a bit nicer to read. So let's input that. Let's implement that with just a simple system.out.println. I know, it's a lot of typing just to get an extra line. Once we have that, we'll have the story shifted down a bit, and we'll want to add a space between the noun and is. So let's go back in our code to line 32 and add a space before is. Oh, the sky is yellow and the weather is so warm. In fact, it's outside. I can't wait to visit the swimming pool. Yeah, let's add another thing here. And go. I can already tell that this will also need a space. Now, it did have a problem. That's because when I entered swimming pool over here for place, what happened was I added a space. And this space has a very special meaning to the computer. It's kind of like a separator. So what happens is the computer takes in swimming and stores it in place. And then once we have the space, it kind of runs to the next line and does line 27, and then it goes to line 28, and it gets input. But since I already had pool kind of lined up in the system in queue, it takes in pool and stores it in verb instead of whatever I was going to put here. So that is something important to note. Sometimes users can do stuff that breaks your program, and that's why we'll have to error trap. But for today, we'll just have to accept it and maybe put a bit of a disclaimer at the beginning of our code to ask our users to please input one-word answers only. So let's go ahead and do that. At the beginning of all of this, let's print out a line that introduces this Mad Lib to the user. We might as well welcome them into our program. Welcome to Mad Libs, so we'll have that displaying at the top. And let me just clear this out so I can have more space. And for formatting purposes, let's add just a line to break up the sentences and make it a bit easier to read for the user. And then we'll ask them to please answer in single words only. Alright, and another line to format. On that note, there is actually a shortcut that I can use because this is a lot of stuff to type for just an extra line. What you can do is instead of having this, you can put a \n where you want an end line. And this \n is just the equivalent of this, but much shorter. So let's do that. A \, then an n. So we can save ourselves a bunch of text. Okay, let's give it a try. Welcome to Mad Libs, and then we have the extra space because of that \n. Please enter one-word answers only, and hopefully the users listen. Enter a noun, a bed, color, yellow, a number, a place. Now, earlier we said swimming pool, but because that's a two-word answer, we'll need to switch it. Let's say library. Now, what we get is a full story, a very wacky story, and it's a lot of fun. If you want, you can do some more debugging and see how you can better optimize it as well, but I think we're good to go with this. Oh, I guess if we're really being picky, we can add a period at the end. This will only take a few types. So let's just add another period at the end. Alrighty, I didn't really need this space. Alrighty, so I'm not going to run it again, but when you do, you should get an extra period after your verb. Alright, now we'll get into the new stuff for this lesson. We are going to talk about control flow. And control flow is exactly what it sounds like. How can we control the flow of the computer through our code? So far, the computer's just been reading line to line, from top to bottom, like it starts at line 1, then goes to line 2, then line 3, and so on until it reaches the end. But that's not always the case. Sometimes you need to get the computer to make choices based on a condition, and then skip certain sections of the code. On the left, I have a chart of some control flow statements in Java. Today we'll learn about the if-else statement, which is the one in teal, and this is a type of decision-making statement. It asks the computer to choose a path based on a certain condition. This executes a block of code if a condition is true. If it's false, another block of code can be executed. Executed just means run. Now, here's an example of an if-else statement that we use in our daily lives. If it is raining today, we bring an umbrella outside. Otherwise, we don't. That's exactly what this flowchart on the right shows. If it is raining, bring an umbrella. So rain is the condition, and we're asking if it's raining or not. If rain is true, so it is raining, then bring an umbrella. If rain is false, so it isn't raining, then don't bring an umbrella. This is a really simple example, but it gets the point across. Let's go over to Replit and try it out in code. I'll go over and start a new file first. I'll name it if else, and then I'll create it. Okay. To create an if-else statement, you just need to follow this format. You'll have an if, and then you'll have some condition in here. I'm just going to put the word condition in here as a placeholder. And then you'll notice that the computer automatically indents for you. That's because it wants you to indent properly so you can see your code better. I'll talk about this in a bit. What you need next are some scope brackets. You need an opening scope bracket and then a closing scope bracket. Then whatever you want to put as code would go here. And then you have your else statement, and you don't need to specify a condition at else because the code will just automatically go there if the condition is false. You'll still need scope brackets though. These brackets are really important. Their job is to contain sections of code, so it's really important also to indent so you can see the different sections of code clearly. What you'll see here is that this top part is completely separate from this bottom part. The computer gets to line 3 and then it reaches the if-else statement. Here's where it reads whatever the condition is. It'll read the condition, then it'll ask itself if it's true or false. If it's true, it does this, and then it'll skip over else and end the program. If it's false, it'll skip over this first part, it'll skip over the code at line 5, and it'll go straight to the code at line 9. Let's try out an example first. Say we had a number variable, so I'll just go up here and declare a variable int number. We'll set it to be 11. Now we'll make our condition about that number. If number is bigger than 10, so remember the operations from last lesson. This is a greater than operator. If number is greater than 10, let's just print out a simple line. So we'll print out the number was greater than 10. We won't be too creative today. And otherwise, we'll just say the number was smaller than 10. So before even running the code, we'll already know right away that the computer is supposed to choose this one, because 11, which is what number is set to right now, is indeed greater than 10. So after it prints out this line, it'll skip the else statement entirely, so it won't even go here. It'll just end the program. It'll go to 15, 16, then end. I'm going to run the program to show you. And the number was greater than 10, which is exactly what we expected. It ran the code at line 8. Now, if the number was smaller than 10, let's say it was 7, it should run the code at line 13, but not the code at line 8. Oh wow, it's raining really hard outside, where I live at least. And the number is smaller than 10, which is exactly what we expected. Perfect. But there is one more case that we haven't covered. What if the number is 10? If the number is 10, what happens? Here, it still goes to the else statement because, like I said earlier, if the condition up here is false, the Java automatically goes to the else. Else is kind of like your catch-all garbage system. Whatever doesn't fit in here goes in here. But the thing is, 10 is not smaller than 10. 10 is the same as 10. So we need another condition for this certain case. And that's where the else if system comes in. So there's actually one more possibility called an else if. And you also need a condition and you also need scope brackets. This else if is just like another scenario. You can have as many as you want. Like you can have a third scenario, a fourth scenario. You'll just need a bunch of else ifs if you want to use more. Now, for our case, if 10 was equal to 10, we wanted to print out the number is 10. The number, well, maybe the number is equal to 10. So what that looks like in code is else if number is equal to 10. Now if we run it, it should run this line. Because it goes down here, it skips this first part because it's not true, and then it goes to this part. I just realized I forgot a semicolon, that's why we got an error. Wow, it really was raining. I guess my example with the rain really manifested it in our weather. Yeah, so we do get the number is equal to 10. That's pretty much if-else statements. They're pretty simple, but you'll find that it has a lot of uses. In our next lesson, we'll start off with a project using if-else statements, but for now, I'll just let you digest this new info for a bit and maybe play around with it. That's all for this lesson. Hope you enjoyed and see you at the next one.